Mathematics made easy, no more fear. Target online class, we got you. Wherever you want it from, we got what you need. Target online class, we got you.
Good day, everyone. Once again, you are welcome to Target online class. Just as I've introduced the set of numbers, so the first set of numbers. The first set of numbers are called the natural numbers. The natural numbers. So denoted, this one is denoted as n, as we have it on the bottom. Good day, viewers all over the world. You are welcome to Toydel online class. Today we want to look at the derivative of logarithmic function. That is, we want to look at the derivative, the differentiation of logarithm function. So before then, I have about 6 or 7 videos on introduction to differentiation, limit of a function of a function, derivative of a product rule, quotient rule, or the derivative of exponential function and trigonometric function. So today we want to look at the derivative of logarithmic functions. We know that if y is equal to log ex, this is called the natural logarithm. Please, you can check my video on logarithm and logarithmic equations. I have a video on logarithm and logarithmic equation so that we have proper understanding about logarithm. We can have log x base a. This is the logarithm. But when the base is e, is a natural logarithm. So this one is referred to as natural logarithm. So it's referred to as natural logarithm. E has its own value. So please, before you can understand the derivative of logarithmic function, you must understand logarithm very well before you can do this. So if y is equal to log x base e, this log x e is known as in x because this is a natural logarithm. If y is in x is same thing as log x base e, then the y dx will be equal to 1 over x. That is, if you want to find the logarithm of if a function has a natural logarithm, say x, in this case now is x, it's same thing as you saying in x. If it's log e2, just say in 2. That's natural logarithm. If you want to take the derivative of in x, it will be reciprocal of x, 1 over x. But if y is equal to log x a, that is when the logarithm is a, it's not natural logarithm, then the y dx, the derivative in this case will now be 1 over x in e a. That's what we are going to get. And of course, we can actually show this. That is, if the derivative, if a function is log xa, if a function is log xa, then the derivative will be 1 over x log ea. So we can actually show that. But please, I want you to check my videos on logarithm, or you go to standard textbook or YouTube. So there's some other videos on YouTube channel on logarithm. So if you understand logarithm very well, the loss of logarithm, and the change of base, then what we are discussing here will be very simple and straightforward. But for the purpose of this lecture, for the purpose of this class now, note that if y is in x, that is log xe, the derivative is 1 over x. Then if y is log x base a, it could be any number. It could be any number. It could be log 3. The derivative is given as what you have here. So I would love to take example just to buttress my point on this concept. Example. Let's say example 1. Find the derivative. Find the derivative of each of the following. Find the derivative of each of the following. A, The first one, we have log sine xe. Then b we have x log xe, that is x square. Then probably let's say one c, the third one, we have log 1 plus 2x all squared e. Okay, this is what we have. So how do we solve this? We start from the first one. Where the derivative, where we have y to be equal to log sine x e, and log sine x e is same thing. Log sine x e that we have here is same thing as n sine x. That's what we are going to get, because natural logarithm is called n. So we can say, but in this case now, we have sine x, so we might not be able to do. Of course, we can do this directly, because when we in this case now, y is in sine x. So the derivative of this now, of course, because this one is in and it's not ordinary value, it's trigonometric function, we can represent it as something. Okay, let me do it this way. I'll just say, let u to represent sine x. Okay, so that my y can be equal to log ue, which is same thing as in u. So if y is in u, then dy du in this case now will now be 1 all over u. Represented by substitution, 1 all over u. Then when I have du to be equal to sine x, du dx will be equal to cos x. The differentiation of sine is cos. Therefore, the y dx will be equal to what? The y dx will be equal to du dx multiplied by dy du. So in this case, what is du dx? Du dx is given as cos x. We have cos x multiply by dy du is 1 all over u. 1 all over u. Then what is u? U is sine x. So at the end of the day, we are going to have from there now. From there, let me just clean this space. From there, we are going to have here, we are going to have cos x all over u. So finally, dy dx will now be equal to cos x all over u. U is sine x, so sine x. And of course, I might decide to stop the answer at this point, or I can proceed further. I will say dy dx is equal to, this is reciprocal of this same thing as, it's reciprocal of tan, that is this same thing as 1 over tan x, and that will give us cot x. So that's value of dy dx. So if you are very vast on the trick, so you know that sine, cos all over sine is reciprocal of tan, and 1 over the reciprocal of tan is cot. So we're going to get cot. We are going to get cot. We are going to get cot x as an answer. So we go ahead and do the second example. The second example on example 1, b, where we have y. B, we have y to be equal to x squared log xe. That is, this is what we have. In this case now, what do we do? This same thing as you saying y is equal to x squared log x. When it's natural logarithm, log e is same thing as nx. So this is the product of two functions. This polynomial function, and this is logarithmic function, logarithm and polynomial. So we have product of two functions. Then if that is the case, we are going to use, in this case now, we are going to use product rule. So I will denote one as u, the other one as v. So u is equal to x squared. Du dx will be equal to 2x when I differentiate this. Then v is equal to nx. So dv dx will be equal to 1 over x. When we differentiate natural logarithm, is 1 over is the reciprocal of what we are given. Therefore, dy dx under product rule will now be u dv dx plus v du dx. So if you substitute u, in this case, u is x squared multiplied by dv dx. Dv dx is 1 over x plus v is in x multiplied by du dx. Du dx is 2x. So if we solve that, if we do that correctly, x can take care of x. At the end of the day, we are going to have x plus 2x in x. That's what we are going to get. And the only thing we can do here is just to say bring out x. At the end of the day, we have 1 plus 2 in x, and that will be the final answer. So this type of question now, we are going to apply product rule because it's the product of two functions, polynomial function, s squared, then logarithmic function. So we go ahead and take the third one, the third question under example one, the third question, C, under C, under the first example. So let's take the third question. The third question is where we have y to be equal to log 1 plus 2x all squared e. So that's what you get. Because what you have here is is something that we can actually we can expand. Then we can represent everything here as maybe u. That is, say let u be 1 plus 2x all squared, so that we find the u dx. Of course, if you want to find the derivative of this, you can use function of a function. That is what you have in that bracket is called core. Differentiate this. If you differentiate what you have in the bracket, the answer will be 2, because the derivative of constant is 0. 2x is 2. You have 2. Multiply by, I'm applying function of a function here. Multiply by, this 2 will come down. 2 into bracket 1 plus 2x. Then you subtract 1 from this to that one. So I don't do any, I'm not going to do anything on this. So I'm going to get 4 into bracket 1 plus 2x as my du dx. Then here I will have y to be equal to log ue. So dy du will not, which is the same thing as in u. Then dy du will be 1 all over u. And that's what we are going to get. So dy du will be 1 all over u. And that's what we are going to get. From the inception, we have said that. So here we are going to have 1 all over u. So dy du is going to be, this will be in u. So we have log. So y is equal to this. So at the end of the day, dy dx will now be du dx multiplied by dy du. So du dx is 4 into bracket 1 plus 2x multiplied by 1 all over u. And of course, we are given the question in the form of x, not u. So we recall that in this case, if we multiply, we are going to have 4 into bracket 1 plus 2x all over u is 1 plus 2x all squared. So this can take care of this. So that at the end of the day, the value of dy dx, from there now, the value of dy dx will now be equal to 4 all over 1 plus 2x, and that's what we are going to get. So that is what we are going to take. We take another example. Let's take another example. We take another example, say example 2. Let's take another example. Example 2. So here now, we take another example. Example 2, find the derivative of the following. Let's just take 2 questions here. A, the first question. Let's take 2. The first question now. A, we have ex log s raised by e. Then B is where we have log a. Log a, that's the second one, is where we have log a 1 plus x all squared. That's what we have. Okay. So let's take this second example. Solution. This is the first one, where we have y equal to e raised to power exponential x log se. This same thing as exponential ax in x. That's what we are going to get. Still a question, another natural logarithm. Then if that is what we are given, we break this down into 2. So without writing the product rule, I can just do this straight away. You call this one u, this one v. So u is equal to e raised by x. Then du dx retain its value, e raised by x. We have done that under the derivative of exponential function. Then in this case, we have v to be equal to in x. Then dv dx will be equal to 1 all over x. Therefore, the y dx will be equal to u dv dx plus v du dx. Then in this case, u is given as ex multiplied by dv dx is 1 over x plus v is given as in x multiplied by the u dx is e raised by x. So if we simplify this, we're going to have e raised by x all over x plus e raised by x in x, and that's what we are going to get. Of course, from here now, we might decide to bring out e raised by x, so that we have. No, let me write it. I can write it here neatly. That is, we might decide to, from here we can say dy dx will now be equal to, let's bring out e raised by x. Then what do we have left? So I'm about to write the leftover. If we do that here, I'm going to have 1 over x left here plus in x, and that's what we are going to get. So that will be the final answer. And of course, we know the meaning of in x. We can write this as e raised by x into bracket 1 over x plus log xe. So that is the answer. That's what we are going to get. So that's that about that. Then the last question now, we want to solve the question under the other logarithm that is not natural logarithm. That is, we are given, let's simplify let's solve the last question. Here we are given y, or let's say we are given y to be equal to log 1 plus x squared a. That's what we are given. So here I can say let u equal to 1 plus x all squared, so that du dx can be equal to, the 2 can come down, 2. No, I will differentiate what I have inside the bracket. I want to apply function of a function here. So if I apply function of a function here, it simply means that I will differentiate what I have in the core. Inside this bracket is called core. What we have here is called core. So if I differentiate this, I'm going to get 1 multiplied by this 2 can come down into bracket 1 plus x, then 2 minus 1. That's what I'm going to get. At the end of the day, I'm going to get 2 into bracket 1 plus x. That's what I'll get as du dx. So that y will be equal to log ua. Y will be equal to log ua. So if I differentiate dy du, I'm going to get 1 all over u log ea. Please check from the outset. If your function is not a natural, it's not the natural logarithm, that is the base is different from e, then the derivative is given as this. So at the end of the day, I'm going to combine the two. I will now say dy dx will be equal to du dx multiplied by dy du. So du dx is 2 into bracket 1 plus x multiplied by dy du is 1 all over u log ea. Then this same thing as when I multiply, I'm going to have 2 into bracket 1 plus x all over u is given as 1 plus x all squared log ea. This will take care of 1 here. Then at the end of the day, I'm going to have 2 all over 1 plus x log ea. And that's what you are going to get as the final answer. So I want to advise that for us to be able to understand this derivative of logarithmic function, there is need for us to have vast knowledge about logarithm. So I have a video on logarithm where I explain the difference between natural logarithm and the other logarithm. So we can know the change. For us to be able to get this, it requires the change of base. But just note that if y is given as log either x, whatever, and the base is not e, once this the base here is e, it becomes in x. That's natural logarithm. But if it's ordinary, it's another value apart from e. This is how we write the derivative. So I'd love to stop here because of our time. Thank you for listening, and God bless you.
Mathematics made easy, no more fear. Target online class, we got